Objects. JavaScript objects can be thought of as collections of key-value pairs. As such, they are similar to dictionaries in Python, hashes in Perl and Ruby, hash tables in C and C++, hash maps in Java, associative arrays in PHP. JavaScript objects are hashes. Unlike objects in statically typed languages, objects in JavaScript do not have fixed shapes. Properties can be added, deleted, reordered, mutated, or dynamically queried at any time. Object keys are always strings or symbols. Even array indices, which are canonically integers, are actually strings under the hood. Objects are usually created using the literal syntax. So they're giving us an example. We can copy it, and we can go here. You can open any tab and just press Ctrl Shift I, and now we're gonna paste it here. So here we have a const object for obj. It's gonna be assigned open curly braces, and then we have properties, in this case name, for details, and inside details we have another object again with some properties. We have color and size. So for example, the name here is going to be caret. This is a string. This property size is inside this property details, and it's going to be a number. So for example, if we press enter, nothing is going to happen because we need to cancel that log. So what we're going to do is, okay, cancel that log, and we're gonna cancel that log the name of this object. So the name of this object is obj, and let's say we want to grab, I don't know, the name. So what we're gonna do is the name of the object, obj dot name. Okay, and then we press enter, and what we are gonna pretty much retrieve or fetch is gonna be this stuff, caret, the name. So we press enter, and there you have it. Now you can do the same for example, and details. But let's say you want to know the size or the color and details. So what you do is, instead of just object.name, what you're gonna do is object.details. So it's gonna be details and then another dot, and this time it's gonna be, you have two choices. See, color of size. Let's go for the size. So we're gonna retrieve a number, not a string. So we're gonna retrieve the number 12, and there you have it, 12. So this is a basic example here. Object properties can be accessed using the dot, as we saw here, or brackets. When using the dot notation, the key must be a valid identifier. Brackets, on the other hand, allow indexing the object with a dynamic key value. And by the way, for example, this is JavaScript. As you can see, objects. Do not confuse it with JSON. As you can see, when you have JSON, you have what is the name of this? Key value pairs, but they are both in double quotation. So for example, you have type inside a double quotation, and then the value, this is the key, this is the value, would be again in double quotation. Here they give us another example. Here we have the dot notation, and then we have the bracket notation. So here we have the object.name Simon. We end up with a semicolon, and then we have the const name is assigned the object.name. For example, if we grab it, we copy, we paste it, and we go to, okay, we can clean it up with, you press here or just type in Ctrl+L. Okay, Simon. This is the dot notation. Now for example, if we go here to the bracket notation, let's grab this example here real quick. Okay, So we have the object. Now we open brackets, and inside the brackets we put the string, in this case name, and then we assign it to that string. Again, Simon. Okay. Now we have here, can use a variable to define a key. So here we're using the prompt. Let's grab this example here. And counts username is assigned to prompt, what is your key, then object, open brackets, then we put the username, is assigned to prompt, what is its value. Let's try, here it is, what is your key, okay, what is your key, I don't know, green, let's say. Okay, what is its value, I don't know, 1. Okay, so this is another example. Property access can be changed together. So as I show you an example here, I already deleted, but you have object that details that color, and it's gonna be orange. Let me see. Yeah, I think it remembers it. Let's see, let's try it. Yeah, it's gonna be orange. It remembers it. So I don't know if you remember the size, it was 12, so if I put size here, it's gonna come 12. See? Okay. Objects are always references, so unless something is explicitly copying the object, mutations to an object would be visible to the outside. So here we have another example. Let's clean it up here. Okay. And we paste it. So we have the counts object is assigned to an empty object. So here we have a function, do something, we pass an argument, this argument is O. Then here in curly braces we have O that X is assigned the number 1. So now do something, here we have the object, and now we're console.log object.x. So the result is gonna be 1 because here we're using as an argument O, but here we're using as an argument the object.x. And for example, if you want to do instead of just object.x, if you put object.x, the result is gonna come 1, as you can see. But if you only console.log the object, so we have this the value and the key per value keys. So you have x colon 1, and you can check out here the prototypes, you have the constructor, a bunch of information here. So and you can do the same thing, but what is how we work here. Yeah, this also means two separately created objects will never be equal. So will never be equal. You represent it with exclamation mark and the double equal sign, because they are different references. If you hold two references of the same object, mutating one would be observable through the other. So here we have another example, but this time, okay, let's clean it up here and paste it. We have the counts me is assigned to an empty object, so counts still me is assigned to me this time. Now me.x is assigned to 1. If we cancel that log still me.x, the result is gonna be 1. Now if we console that log only still me, we're gonna get the result a key value pair. It's gonna be x colon 1. Okay, and here for more on objects and properties, see the object reference page. For more information on the object initializer syntax, see its reference page. This page has omitted all details about object prototypes and inheritance, because you can usually achieve inheritance with classes without touching the underlying mechanisms, which you may have heard of to be abstruse. To learn about it, see inheritance and the prototype change, so you can check